Hey everybody, let's start out by talking about polygons. So if we take a look at our, if we take a look at our definition of what a polygon is, we know that a polygon is any shape that is a closed figure with straight lines. So the shapes that we're taking a look at today, which are going to be all of these shapes, as well as all of these shapes, are all polygons, along with all of the triangles that we've looked at. They're all polygons as well. So the thing that sets these apart from the triangles that we've looked at is that these shapes are quadrilaterals. Remember, quadrilaterals are polygons that have four sides. So four-sided polygons rather than the three-sided polygons that we've been looking at. So in addition, all of these shapes here and here are also quadrilaterals because they all have four sides and they're all polygons. So if I called any of these shapes a quadrilateral, great. If I called any of these shapes a polygon, great. Now, the new terms that we'll be talking about are parallelogram, trapezoid, rhombus, rectangle, and square. Now, when I say new, I know that you guys know what those words are. I know you know what those shapes are, but we're going to be classifying shapes in more than one category today. So we're going to see how that works. So starting off, let's look at a parallelogram. The definition of a parallelogram says any angle that has opposite angles congruent. Now, guys, when I'm talking about opposite angles that are congruent, just to give you a picture of what that looks like, I am basically talking about, for instance, this angle up here and this angle here, and then this angle here and this angle here. Those angles are opposite angles. And the word congruent just means that they're the same. So if I was looking at shape A here, I would say these two angles are the same. They're both right angles. These two angles are the same. They're both right angles. So that shape has opposite angles congruent. The second thing you need to have in order to be a parallelogram is you have to have opposite sides congruent. Now, just like with angles, works the same way with sides. It means this side and this side are the same length, and this side and this side are the same length. So the opposite sides have to be the same. And then the last thing you need to be a parallelogram is the opposite sides have to be parallel. Now, guys, remember the word parallel means that you have two lines that aren't touching. So that these two lines, the top and the bottom, will never touch. They'll touch the sides, so they'll touch, we call these adjacent sides, but they won't touch the top and the bottom or the left and the right. So the parallel lines could be going up and down, side to side, sloped this way. It means that those two lines are sloped the same when they're parallel. So you have to have all three of those things in order to be a parallelogram. So if I went back through and started to classify some of these shapes as parallelograms, I would have a bunch. I would say that A is a parallelogram, and we'll put it there. A is definitely a parallelogram. Going back, B is a parallelogram. It fits all three of those categories. C is not a parallelogram. It doesn't have any of those three categories that it fits. D is a parallelogram. Fits all three of those categories. E is a parallelogram. It, again, fits into all of those categories. F is not. It does not have any of those things. G is a parallelogram. Again, fits all three of those categories. Has to fit all three. H, again, is not. I is close to a lot of people, but it's not. You'll notice that the left and right side here are not parallel. The top and the bottom are not parallel. It actually doesn't fit any of those things, but it kind of looks like it does. J is also not. J is actually a kite. You'll notice these two lines are not parallel, nor are they the same. K is a parallelogram. So out of all of those shapes that we had there, we have some that were parallelograms, some that were not. All of these shapes, A, B, D, E, G, and K, are parallelograms, um, based upon fitting those three categories. And again, those three things were opposite angles are congruent, the opposite sides are congruent, and the opposite sides are parallel. That makes those things parallelograms. Now, from that category of parallelograms, we can basically break it down into two main categories. The first category we're going to talk about is a rectangle. So in order to be a rectangle, and you'll notice in the picture here, it shows this, we have to have four right angles, four 90-degree angles. We have to have the opposite sides that are congruent. Now, one thing that people don't realize here is just because it says opposite sides congruent, it doesn't mean that all of the sides can't be congruent. Because if all the sides are congruent, the opposite ones are going to be as well. And then again, the opposite sides have to be parallel. Those four right angles are going to be the big thing here. Now, if I look at my parallelograms, some of these parallelograms also qualify as rectangles. So the first one that we're going to look at is A, is definitely a rectangle. Now you might be thinking, well, A is a square. Squares are rectangles, guys. Every square that you're ever going to see is going to be a rectangle as well. Um, B kind of looks like it, but you're going to notice if you look really carefully at B that the angles aren't exactly right angles. So it's not going to be, actually, let's make that one a little longer so it's a little more obvious. There we go. Maybe that's a little easier to see if I draw like that. Those angles aren't going to be exactly right angles, so we're not going to call that a rectangle. D is a rectangle. D is a rectangle. E is a rectangle. It has all three of those things, including right angles. G is not a rectangle. You'll notice it does have opposite sides congruent. It does have opposite sides parallel. It does not have four right angles. Therefore, it's not a rectangle. And K is a rectangle. So looking at that, you'll notice that of all of these parallelograms, 4 out of 6 of them were rectangles. Now, the only ones that weren't were B and G. Now, those could fit into a different category, which is a rhombus. Now, a rhombus, again, has to have three things. Has to have opposite angles that are congruent, the same. It has to have 4 congruent sides. So this time, not just the opposite sides, but all 4 sides have to be congruent. And it has to have opposite sides that are parallel. So similar to a rectangle in a lot of ways. So when I go back, I'm going to try to classify E and G, and I'm going to think, are any of those fitting into the category of rhombus? Well, or sorry, B and G. B definitely fits into the category of rhombus. It has 4 congruent sides, it has opposite angles congruent, and it has opposite sides parallel. Now, G does not fit into that shape, not into that category, because G does not have 4 congruent sides. Now, from here, we're also going to look and see, do any of our rectangles fit into that category of rhombus? Well, 2 of them do. A is definitely also a rhombus. Again, it has all 3 of those parts of a rhombus, and as well, E is also a rhombus. So from this point, we have all of these are parallelograms. Now, you'll notice the only parallelogram here that didn't fit into any other category is G. G is a parallelogram. We could call it a quadrilateral, 4 sides. We could call it a polygon, but we can't call it anything beyond that because it's not a rectangle. It's not a rhombus. All of the rest of these shapes we could call quadrilateral, polygon, parallelogram, and then something further than that. Now, you'll notice a couple of these shapes. Shapes A and shapes D fit both into the category of rectangle and rhombus. That's because A and E also fit into one more category, which is a square. A and E are a square, and squares fit into all those categories. Squares are rectangles, squares are rhombuses. Um, so they fit into both of those things. Squares are polygons, squares are quadrilaterals. So we could call those any of those shapes any of those different names. Now, if I said that every square is a rectangle, that would be very true because a square has to be a rectangle. If I said that every rectangle is a square, that would be false because you'll notice here I have multiple rectangles, D and K, that are rectangles, but they don't have four equal sides, four congruent sides, so they're not squares. Um, so it is true that some rectangles are squares, but only if they're squares, which is kind of confusing. And the same thing works with rhombuses as well. So then we have that category of squares. So if I was going to write down, on my pen, I take that back, all of the different categories that a square would fit into, we would say definitely they are polygons, they are quadrilaterals, they are parallelograms, they are rectangles, they are rhombuses, and they are squares. So all six of those different categories we could say that they would fit in. Now, if we go back and look at our original shapes, there is one more category for these non-parallelograms that we can have, and that is a trapezoid. And a trapezoid is a quadrilateral, so it's a polygon, and it only has one set of parallel sides. You'll notice here at the top and the bottom. And out of these shapes, we did have two actually, two trapezoids, and that would be shape F, which we'll put here, and also shape H. And those were both trapezoids. So if you go through, you'll notice which of these shapes fit into multiple categories here, and which of these shapes do not. So it's kind of foreign for us to think, but we can classify shapes in different categories with more than one name based upon their features and based upon what they are. So a shape could fit into more than one category. And that's something that I would like you to think about. So think about that. Bye, guys.